Hi, I'm Kevin from Aston Engineering Services and welcome to our YouTube channel. We were looking at the videos that we've done previously and it was noted that we've done many videos on the Aston Martin V12 engine and the V8 engine and DB2, but we've neglected the Tadek Marek 6-cylinder engine that ranged from the DB4 through to the DB6. This is an all-aluminium 6-cylinder engine that was originally started life in the DB4. In the DB4 it had a capacity of 3.7 litre with twin SUs. Then it went to DB5. The DB5, the capacity was enlarged to 4 litre. Then that remained through the DB5, DB6, DB6 MK2, and finally the DB6. The engine didn't change an awful lot throughout that period. You could have vantage specification, so in the early days of the DB4, it was originally known as the SS spec, so DB4 SS. Now, the 3.7 DB4 had 2 SU carburetors. If you opted for the SS spec, which was made in limited numbers, you'd get 3 SU carburetors. And then it changed to vantage specification in the DB5, where standard you had 3 SU carburetors and the vantage spec was the 345 DCOE 9 carburetors. Now, the engine capacities were 3.7 and 4 litre. The increase in capacity from 3.7 to 4 litre was a change in liner size, liner and bore size. Now, there's additional capacities over and above that that we'll talk through a little bit later on in the video. So what we have here is a DB5, Aston Martin DB5. This is coming for a comprehensive rebuild. It's in the final stages. We're just setting the cam time in and finalising assembly, but everything in this engine has been completely worked through, inspected, remachined. It's been rebuilt to 4.2 specification, so we've changed the capacity from 4 litre to 4.2. Now, these engines have been really heavily developed over the years, and fashion sort of changed. Going back 10 years, 15 years, we was getting as much horsepower and torque out of these engines as we possibly could. Big carb conversions, different camshafts, higher compression ratios, changes in capacity. The racing boys used to use a 4.5 capacity engine that was larger bore again from the 4.2, but the stroke remained the same on the crankshaft for the racing restrictions placed upon them. You can go from 4.2 with a certain bore size up to 4.7 litre. The 4.7 litre is a change of crankshaft and increase in stroke, 11 millimetres larger stroke, and you can go up to 5.2 should you so wish, using the 4.5 cylinder bore and a increased stroke crank as well. But times have changed, and these cars have always been precious, but they're even more so now, and the change in fashion is originality and durability. So that's what we build into our engines here at Hudson Engineering, and we try and do things in a to make sure everything is as original as possible, but change some of the processes to increase durability. The increase from 4 litre to 4.2 litre capacity gives quite a significant amount of torque, and you really feel that when you're driving the car, but it's now classed as not a move away from standard. There's probably more 4.2 litre Aston Martin DB5s, DB6s DB6 is knocking about a 4.2 capacity than what there is the original 4 litre. So this has been comprehensively rebuilt to allow for the use of unleaded fuel, so all the valve seats have been changed, valve guides. We've used the original crankshaft, which has been reground. Everything's been toleranced and measured, and we've used the Cosworth 4.2 pistons, but we've used a longer connecting rod as well, a forged steel, a H-beam steel connecting rod, just changing that ever so slightly. The engines just run that little bit smoother with that, and they produce a little bit more power. But ultimately, it's been built for durability and originality. So a little bit of an insight into some of the technical details surrounding these engines. On the DB5 here, we're just about to set the valve timing. It can look a bit complicated with all these dials sticking out and degree wheels and stuff like that, but it's a relatively simple thing to comprehend. What we do is the piston is moved to top dead centre, which is at the top of its travel as it goes up and down. That's recorded as a 0. Then the inlet cam needs to be in a certain position. The exhaust cam needs to be in a certain position, and then what we do is we rotate the engine and make sure everything's opening and closing and doing what it should in various periods. So on the manual, what you would do is just follow the settings and open an inlet valve to X amount, open the exhaust to X amount, and then tighten the chains, nip everything up, rotate and make sure everything's in order. What we like to do is we go a little bit further, we follow the book, and then we follow each one. We go round a couple of revolutions with the crank, making sure that the peak opening and closing is where it should be. And we check each cylinder as well, because the phasing of the cam from one lobe to another lobe can differ, and we just check that that's all in order, and we try and find a balance and a happy medium. So this is the DB5 in almost the final stages. Now this is a DB6 engine in an earlier stage, similar specification, 4.2 also, but without the changing connection rod. Now, as you can see here, it's just a bare block with liners, one piston in. So it's a forged Cosworth 4.2 litre piston. Now, we have one in cylinder number 6 here. That's installed with a rod on the crank, and that's at the utmost north of its travel, which is called TDC, top dead centre. So these Cosworth pistons were supplied by the client actually, and they come with a nominal compression ratio, which is really high, really high, to the extent where if you just put these pistons in this engine and ran it, the compression would be so extensive that the fuel and air mixture would explode, it wouldn't burn, and it'd cause detonation. Ultimately, you'd end up melting pistons and the engine would fail without doubt. So what we do is we put one piston in, nominal, usually number 6. We move the piston to the top. We measure that and make sure it's at absolute top dead centre with the piston in the bore. Then what we would do is fit the cylinder head. So having looked at the cylinder block assembly for the DB6, the piston is at top dead centre with the dome protruding out of the top of the bore. Now what we need to do is we need to look at the space that's left inside that cylinder, and we need to work out what it is now and what it should be. Now this is the cylinder head off the DB6. This is actually one of the new cylinder head, a brand new cylinder head, beautifully done. We're making these in very small numbers. If you need a cylinder head, please contact us, because they're getting snapped up pretty quickly. But what we'll do with this head now is we insert 2 valves into cylinder number 6, which is the same cylinder. The piston's in. Then we'll dummy fit the head. We'll put a gasket on and we'll torque the cylinder head down. And then what we'll do, using a burette and a fluid, we will fill the cylinder with the piston at top dead center and just see what volume we have inside there. Then we work out the bore and the stroke and what compression ratio we have, and then what we need to go to in terms of the machining of the piston, which will be the next step. So the next part in the process, having fitted the cylinder head and as a dummy and worked out the chamber volume, what we now need to do is machine the piston. So the amount of piston that's sticking out above the bore, we need to reduce that so we can get the correct capacity inside the combustion chamber. So the way we do that is we set the piston up on our machine here, and we'll machine some material off the top, and then we'll back in the engine, and then we'll double check. When we're happy that everything is exactly as we want it, we'll machine each pistons to exactly the same amount. So what we'll do now is we'll just set this away. So having removed the setter mount from the top of the piston, it'll but now be removed from the machine, and we'll put the piston ring back on, and we'll put it back in the cylinder, bring it up to top dead center. We will then measure the capacity and see where we're at in terms of compression ratio. So the compression ratios are set specifically to what the requirements of the engine are. And in some cases also we look at the compression ratios where the engine might be going to. If the vehicle is going to a certain country where we know the fuel quality is very, very poor, we can lower the compression ratio accordingly. And that's, we really tailor each engine to the exact specifications for the client. So I hope you've enjoyed today's video, just touching on some of the aspects of the Tadek Marek 6-cylinder engine. We've seen the DB5 engine there near completion, and the DB6 MK2 engine, which we're machining the pistons for. So I hope you've enjoyed it, and please subscribe, and we'll welcome you back next time for our next video.